In this video, I will share very important points about parallel combination of a number of capacitors. First of all, let us understand what is the meaning of parallel combination of capacitors. Suppose we have a capacitor of capacitance C1, another capacitor of capacitance C2, and third one has capacitance C3. These are terminals of two plates of the capacitors. If I connect plates of these capacitors at a common point on one side and the terminals of second plate of each capacitor is connected to another common point, and when these common terminals are connected to a battery that supplies charge plus Q, it is connected to positive terminal of a battery and the second terminal is grounded, let us suppose. So this combination of capacitors is called parallel combination of capacitors. So let us calculate the capacitors of capacitor that is equivalent to this combination. Suppose V is potential applied across this combination. So it is clear that same potential will appear across the plates of each of these capacitors, and charge provided by positive terminal of battery will be divided into three portions. Suppose charge plus Q1 goes towards C1 plus Q2 goes towards C2 and charge plus Q3 goes towards C3. It is clear that it is charge Q that is divided into three parts. So mathematically I can write Q is equal to Q1 plus Q2 plus Q3. Now what will happen? This charge Q1 will develop on this plate of C1. By electrostatic induction, negative charge will be developed on inner side of this plate and positive will be developed on outer side of this plate. Magnitude of this charge will be plus Q1 and this positive charge will flow towards ground. So this is plus Q1 and negative Q1 will be left on the inner side of the plate, and this charge will flow towards ground. It is plus Q1. Similarly, here we shall have plus Q2 charge and on inner side we have minus Q2, on the outer side plus Q1 here and plus Q2 here will flow towards this. Same thing will happen here, plus Q3 will be developed on this plate, minus Q3 on this plate and plus Q3 developed on outer surface of this plate will flow towards this common junction. So all these three charges plus Q1 plus Q2 plus Q3 will combine together to give rise to total charge plus Q at this common terminal, which will flow towards ground. So this is how this parallel combination of capacitors works. Now by using the definition of capacitance, we know C is equal to Q upon V, where Q represents charge on the plates of capacitor, V represents potential applied, C is capacitance of the capacitor. So this relation can give us Q is equal to CV. Using this, I can write this equation as Q is equal to C1V plus C2V plus C3V. I have written V potential same because all the capacitors are parallel to each other and same potential appears across the plates of each capacitor. Let me call it equation number 1. Suppose C is capacitance of a capacitor that is equivalent to parallel combination of three capacitors. Suppose this terminal of the capacitor is grounded and this terminal is connected to positive of a battery of same potential, suppose V. As I have earlier explained, positive charge will be developed on this plate of capacitor because plus Q charge is coming from whole charge will be developed here. Minus Q will be developed on the inner side of the plate. Plus Q will be developed on the outer face. It is connected to ground. So this charge will flow towards ground. So plus Q charge will flow towards. This is how this capacitor will function. As I have done earlier, we can write relation for charge Q equal to C multiplied with V. C is capacitance of capacitor equivalent to parallel combination of three capacitors. Let me call it equation number 2. So both equation number 1 and 2 are giving us the value of Q. By comparing equation 1 and 2, I can write CV is equal to C1V plus C2V plus C3V. After simplifying, I can write C equal to C1 plus C2 plus C3. So this is relation for capacitance of a capacitor that is equivalent to parallel combination of three capacitors having capacitance values C1, C2 and C3.